Hello, this is the course of data mining and in this video you will learn about exploratory data analysis based on the basic statistics. In this video I think you will see the basic statistical description of data, and the other video I will discuss about the data visualization. So what is the motivation based on the basic statistical description? The motivation is to understand the data. If you understand the central tendency, it means I want to know where is the central of the data. Then you can have a more understanding about the data. Variation and the spread. We can use the skewness. We can use the standard deviation to understand the spread of the data. And some data characteristics such as the median, maximum, minimum, quantiles, outliers, variance, they are important for understanding the data characteristics. And also we need to understand the dispersion analysis. So the tools to understand the dispersion analysis is the box plot or quantile analysis. There are various EDA, or we can say this is the exploratory data analysis. Okay, we can deal with the data info, for example, the shape or the attributes or the delimiter. Okay. So we will discuss this approach later. Okay, and I think in the orange you already know about some data info about how many attributes you have, and about the shape, of course, you need to know how many rows that you have. And delimiter, it depends on the data type. You already learned about the data sets. Okay, so in the data sets, if you are dealing with the data matrix, so the data matrix is the n multiplied by m. So m, it means the n is the number of rows and m is the number of columns. So if you are using the central tendency, okay, so the central tendency means you want to know where is the mean. Okay? Where is the exact location of the mean? So if we are having good data, then we can say that this data is some kind of normal distribution. But if we are having asymmetric, okay, so this is the asymmetric distribution. So this asymmetric distribution, the mode, the median, and the mean is like shifting. Okay, so using the mean, we can know directly where is the position of the data or where is the distribution of the data. In some other tools or in some other kind of data, you may need to use weighted arithmetic mean. So in the weighted arithmetic mean, you need to put weight. So every data you can put weight, whether weight is what 가중치. Okay. So you need to understand that this data is more important than the other data. Then you put more weight. Or there is a trim mean, so chopping extreme values. It means if you have data, then you don't need to consider some outliers. So some outliers will be chopped or will be cut. Then, for example, there are some outliers here. Then you cut those outliers and then you just consider the data which is in the range. Median. So median means the middle value. So the middle value, if the data range is varied, okay, you may need to use the median instead of the mean. Okay. For example, if the data is like 3 and then 4 and then 5 and then, for example, 7, 10 and 1000. Okay, what is the average? Okay, the average will be 7 plus 12, so 19, 19 plus, okay, for example, I just make it as 11, okay, just easier. So 7 plus 12, 7 plus 12 is 19, 19 plus 11, so it's 30, and then plus 1000, so it means 1030, okay. And then we have only 5 data, so what is the average? We have 206, okay. When we have 206, actually you can see this is a very strange because it is an outlier data. Then in this case, you need to understand the median. What is the median here? Oops. Okay, what is the median here? So we want to find the middle value. So the median will be 5 and 7. Okay, because it is the even number. So it means the median will be 5 plus 7 divided by 2. So it means 12 to 12 divided by 2, so 6. So 6 is the median. What is the reason? What is the good result for this kind of data? Yeah, of course, median is good because if we use median, the result is 6, or the mid value is 6. If you use mean or average, the result is 206. So it is not wise to use the mean in this kind of data. There might be another way to analyze the data about the central tendency is using mode. So in the mode, it is a value that most frequently in data. So it can be unimodal or bimodal or trimodal. It depends on the peak, okay? The peak means the number of frequent data. So if there is only one frequent data, then you can see the peak is only one. So we call this is unimodal. But if the peak there are more than one, so it is bimodal. Or it can be multimodal. Yeah, it's trimodal. It means you have 3 peak. If you have 4 peak, then yeah, you can say yeah, it's the fourth quad model. Okay, and so on. So there's a multi-model. It depends on the number of peak in your data. We can also think about the symmetric and asymmetric. So if it is symmetric, yeah, you can see something like this one. So the mean, median, and mode is in the same place. Yeah? But if it is skewed, okay, so like this one, it is a positively skewed. But positively skewed means you can see the mode is here, the mean and the median is here. But the negatively skewed is skewed on the right one. Okay, so it is the mean, mode, and median is on the right section. We call this is asymmetric. Okay, and the first data is the symmetric. In order to understand about the dispersion of data, we have some measures. We have the quartiles, okay, in order to fit with the Q1 and Q3. So you know about the statistic. If we have this is the median, or the median is the 50 percentile. So the 25 percentile is referring to the Q1, and the 75 percentile is referring to the Q3. Okay. And we have interquartile range. Interquartile range means the Q3 minus Q1. And we have 5-number summary. What is 5-number summary? Yeah, we have the minimum, we have Q1, and then we have median, we have Q3, and we have maximum. Okay, so we have 1, 2, 3, 4, 5. In order to fit with the 5-number summary, we can use box plot. Okay, so the box plot here is a way to show the in order to show the all the things in this measurement for the dispersion of data. So if you can see this box plot, okay, this box plot in this line, you can see that this is the minimum, this is the maximum, and then this is the Q1, this is the Q3, and this is the average, and this is the median. And we can see this is the IQR, so the interquartile range. In the IQR, you can see that sorry, if the data contains outlier, it means the outlier means a value that is higher or lower than 1.5 multiplied by the IQR. So if the data after this one, or if the data is after this one, yeah, it means the data is outlier. So after the 1.5 IQR, after the 1.5 IQR, the data is considered as an outlier. In the dispersion of data, you can also measure about the variance and the standard deviation. So you already learned about the variance and the standard deviation in the statistic. It is also referring to the dispersion of the data. If we have the mu, then the first standard deviation is somehow in the first range of this one. If you are having 2 sigma, okay, so we can, this is sigma. If the range is 2 sigma, then it might be wider. And if you have a range of 3 sigma, then it's also wider, but it means the acceptance of the outlier is smaller. Okay, so it depends on the standard deviation. You can see about the dispersion of the data, and those two are the measures to know about the dispersion of the data. Yeah, box plot analysis, you already I already explained in the first one. So we are having the minimum Q1, median Q3, and maximum, and using those those 5, we can see in one plot. Okay, so using one plot, we can see the minimum, maximum, Q3, Q1, and Q2. So this box plot is represented with the box, and the ends of the box are the first and the third quartiles. The median is lined in the box. Okay, this is the median, and sometimes we can say the like the average. Okay, and the whiskers is to outline outside box, extending the initial, the minimum, and the maximum. And the outliers, we already know from the previous explanation. We can see the data dispersion in the 3D. Okay, so the 3D is something like, yeah, you can see in the more dimensions. Of course, it might be some, there will be some difficulties to understand this data, but this kind of data is like profit and revenue and costs. Yeah, it's necessary to understand those three attributes in the same time. Okay. The normal distribution, yeah, it may give you some understanding about the data. If it is in the range of the 1 sigma, okay, then it's very tight. Okay, so if you have a more like 2 sigma is loose, and if you have 3 sigma is also more loose. So every product, or maybe everything, it can be regarded as in the normal distribution space. But if there is an outlier, then it will not be counted. So in this case, the outlier is very small range, so there should be no error. But here, the error rate might be quite high. Yeah, basically, you understand already about the box plot. Yeah? So it's the basic statistical description in order to understand the data in the 5-number summary. And then histogram. Okay. So histogram is the x and y axis to represent the frequencies. Okay. Yeah, you can just have the histogram like this one. How many of the data that represent in the first section, or in the second section, or the third section. So the quantile plot. So the quantile plot means it is referring to the box plot. Okay, so if you know the quantile of the data, then you can see the box plot. But in the quantile plot, we want to make a pair with some frequency. And there is also another kind of plot which we call the quantile plot, or QQ plot. It is a kind of analysis to understand the quantile of univariate distribution against the corresponding quantiles of another. And scatter plot. So this is the histogram. So this is one example to understand the frequency. So this is the frequency in this year. This is the frequency in this year, and this is the frequency in this year. And then I have this one category, and then this is the second category, and then this is the third category. Okay, so by using this histogram analysis, we can see some cases that fall in this category, and we can see some here in the Ireland and United Kingdoms. I think there are many immigrant, okay, the immigration by decade. So there are many immigrants here compared to the other uh, countries like in the Southern Europe and in Northern Europe. Plot quantiles information. So if you have the data, okay, and I want to see, let's say, the data in the range, the unit price. So the unit price, I want to see the range between, because I know that the data has the minimum 40, and the data has a maximum of like 100, maybe 20. Okay, so I want to know where is the Q1, and then where is the Q2, and where is the Q3, and I want to make it as a plot. Okay. So this is the plot of the quantile information. And you can use also the quantile plot from the two respective data. Let's say this is the data from the branch number 2, and then this is the data from branch number 1. And I want to plot the price. So this is the minimum data, and this is the maximum, and this is the maximum. And from this data, I can see that, okay, the Q1 is here, the Q2 is here, and the Q3 is here. Okay, so some of the price unit for the branch 2 is higher, okay, compared to the price unit in the branch 1. Okay, so yeah, you can see like this one, is 90, and this one is 80. Okay, so yeah, by using this QQ plot, yeah, you can express more visualization in your data. Scatter plot. So usually scatter plot is just for the binary or bivariate. So this is the X and this is the Y. Let's say I want to know the bill, okay, compared to the tips. Okay. So in USA, if you visit a restaurant, then the restaurant, if you are a customer of restaurant, you need to give a tip. Okay. And the tip will depend on the total bill. So let's say this is the total bill, and you want to know how much the tip that the customer gave. And this blue referring to the dinner, and this orange referring to the lunch. And you can see, oh, dinner time, dinner time, dinner time, dinner time. It shows a very big tip compared to the lunch. So the lunch time is like, somehow is less than the dinner time. Then people are more generous on the dinner time. Okay, yeah, we can see from this kind of scatter plot easily. And yeah, when you have some data, you can, if you plot into the visualization, you can see there is a positive correlation, or there is a negative correlation, or it might be both. So the left is related with the, so the left half is about positive correlation, and the right half is about the negative correlated. So those kind of analysis can be also done with the visualization and some basic statistics. And if we understand this one, there are no correlation. Okay, so I cannot do plot anything here, and this is no correlation because it's just like a line, and this also no correlation. Okay? So it's like almost homogeneous. Okay, then I will stop in this video, and I will continue with other video related to the visualization. So thank you very much, and let's go to the next video.